In this video, we are going to go over how to translate a word problem into a system of equations where one equation represents one type of total and the other equation represents another type of total. So this is a pretty cool kind of problem. I'll actually do a second type of word problem on the flip side of this video that's of a different variety, like different subject, but still the same kind of method of solving. So let's jump into it together. I'm stoked. So this says admission to a skating rink is $4.25 for kids and $7.50 for adults. One day, the rink collected $930 and 150 people were admitted. How many kids went skating and how many adults? So I read through the whole word problem because I wanted to know what the variables were that we're solving for. And the question in a word problem often tells you what the variable or variables are that we need. So how many kids and how many adults are our variables? So I'll let K equal number of kids. I'll just put hashtag kids. And then A equals number of adults, hashtag adults. We know that that doesn't mean hashtag, it's number. Silly, Mr. Groden. Or maybe not so silly. Okay, so let's jump in and now translate some equations. So we actually have two totals that we're talking about here. One total would be the amount of money that's brought in. Let's focus on that. We know that that total is $930. So that's one total. So we need another side of the equation that will generate $930. Well, it's $4.25 for a kid. So that'd be 4.25K. Plus $7.50 for an adult. So that'd be 7.5K. I'll eliminate the zero there. And if you think about it, for every kid we'd multiply by 425, that would give us the total money brought in for kids. We add on to that 750, not K, oh my goodness. We bring in from there 750 per adult, which would be A. So if we multiply 7.5 by the number of adults, that gives us the total money brought in for adults. If we add up the total money for kids and the total for adults, we get 930. So this whole equation is focused on total money for what has been earned from kids and adults. The next equation, though, has to do with the total number of people, which is equal to 150. Now from here, we need to think of an expression on the left side that will give us a total of 150. Well, if you take the total number of adults and the total number of kids and you add them together, that would give you the total of 150. So we would have kids, and I'll do K first because it lines up with the K, plus a number of adults, and that will give us 150. We have a system of equations. Quick reminder, it's this part you want to practice again and again and again. So what I'm about to show you how to do is just solving out the system of equations. That's not bad. You want to get to this part and keep practicing it, and then go back and do what I'm about to do. Remember, continue to practice this, then go back through and solve out all the equations when you're first learning this stuff. And as you get better, do the whole thing out as I'm about to complete. Okay, so now I'm going to use elimination because I have two variables on each side, on one side of each equation. So 425, if I multiply that by this equation, we'll line these two up and it's less than 750, so I'm going to go with 425. So I multiply 425 on the entire equation right here, and that's going to leave us with 4.25K plus 7.5A, just copying the upper equation, equals 930. And this lower equation is going to be 4.25K plus 4.25A, that rhymes, equals $4.25 times 150. I already did that out, is 637.5. Might need a calculator for that. So now from here, to eliminate the K's, I need to subtract. So don't be scared off by the decimals. You have a calculator to handle that if you need it. Subtract out the K's, they cancel. 7.5 minus 4.25 is 3.25A. And that's equal to 930 minus 637.5, and that's going to be 292.5. Not bad. So now we divide both sides by 3.25, and that will give us the total number of adults who have attended. So I'm going to bring that math up here. So A, what is that going to be equal to? Well, 292.5 divided by 325 is 90. I'm going to put units here because it's 90 adults. not 90 kids we want to know about. So now from here, I've got that A value of 90. Just like in other systems of equations, I'm going to take that value, plug it in for A in the easier of the two equations, and 750 times A with a bigger number is not nearly as appealing as K plus A. So I have K plus A, which is 90, is equal to 150. And that actually makes a lot of sense. If I had the kids plus 90 adults that we know of, we'll get 150 as a total. So if I subtract 90 from the total of 150, I will get the number of kids, which is 60 kids. There you have it, peeps. If you want to check your answer, of course, plug 90 in for adults, 60 in for kids. In the other equation, you'll get 930. Sweet. On the flip side of the video, I'll show you one other kind of word problem that deals with these different kinds of totals. Can't wait to see you there. All right, here we are on the flip side of the video, where as promised, I've got another word problem dealing with two different categories of totals, and it's a different kind of word problem though in its classic context. It's one of those word problems where I look at it and I'm like, who would ever do this in the real world? However, one, it's a classic word problem, and two, it exercises your brain in how to translate words into mathematical expressions. Let's do it. Gina has some $1 bills and $5 bills. Okay. She has 15 bills in all. She has a total of $47. How many of each type of bill does Gina have? So this is that kind of problem where you look at it and you say, all right, so I've got $1 bills and $5 bills. Those would be the categories. So let's say X equals the number of $1 bills and Y equals the number of $5 bills. All right. So now from there, we go and we notice that there's two different kinds of totals. She has 15 bills in all. So the first equation will deal with the total number of bills that she has. So that's equal to 15. So now on the left side, we need an expression that gives us the total number of bills. Well, if X is the number of $1 bills and Y is the number of $5 bills, if we add X and Y, we will get the total number of bills, right? $1 bills plus the number of $5 bills gives us 15. Sweet. The second equation deals with the total money that she has made up of these bills. So she has a total of $47. So how do we get that $47? Well, the left side of the equation has to give us the total amount of money based on $1 and $5 bills. So X is the number of $1 bills. Well, how much would it then be for $1 bills? It'd be like, I'm not going to put a 1 there, but X number of $1 bills gives us the amount of money, because if I have 5 or 7 $1 bills, let's say, it would be $7, or the number of $1 bills is the amount of money. Then we add on to that the amount of money for $5 bills, which would be 5 times Y. And that's because if I have like 3, let's say Y is 3, if I have 3 $5 bills, that's 3 times 5, or 15 total dollars. If I take the total amount of money in $1 bills, add it to the total amount of money in $5 bills, that'll give us the total amount of money overall. That's it. Again, get to this step, go to the next problem, translate more. That's how you get good at this stuff. I'm going to complete the problem now, which is old school system of equations elimination. The x's line up already, so I'm just going to subtract x from the top equation, bottom from the top. X minus x is 0, y minus 5y is negative 4y. 15 minus 47 is equal to negative 32. Nice. Divide both sides by negative 4. These are nice numbers here. And y is equal to 8. So that would be 8 $5 bills. Always have your units. Now all we have to do is take that y value of 8 and plug it into one of the two original equations. I suggest this first one because it's easier to plug into, smaller numbers, fewer coefficients, numbers in front of the variables. So take that 8 and plug it in here. Actually makes a lot of sense, because what you're saying is the number $1 bills plus the 8 $5 bills is equal to a total of 15. So if you take the total and subtract the amount of $5 bills, which is what we're doing, we'll get x, the number of $1 bills. So that'd be 7 $1 bills. Sweet. That's it, peeps. Translate as you go, but notice that there were two different kinds of totals here. Two, not one. And that gave us a little bit of extra stuff to think about.